Hey, good evening, everyone. Uh, it's quite exciting to stand here because I used to be an audience, just one among you who sits there, probably in that beanbag and asks a lot of questions. So it's a bit alarming to stand here and face the audience. But yeah, I hope all of you know that this is kind of a discussion. It's more of a it's a kind of informal discussions on technology and different topics we discuss here. Uh, it's not like a teaching session. So, so why I'm taking all this bail because I need all of your support, especially those sitting in the back bench. You know, they are the one who actually develops a lot of applications in Swift. So probably we can make it this as an interactive discussion, just like we did last time. I hope all of you have a background on iOS development and Swift, or maybe Objective C. So let's start anyway. Uh, so I'm Sarath. I'm working as a software architect at Experion Technologies. I'm also heading the mobile development at Experion Technologies. So I'm not exactly a full-time iOS developer. So my expertise is across multiple domains, including mobile. So, but definitely iOS and iOS development is something that attracts me a lot. When Apple came up with a new language, over the last 10 years of my experience, I hardly see any new language coming up. Maybe the one I can call might be Ruby on Rails. I mean, Ruby on Rails is a framework, but Ruby. But apart from that, there are not much popular languages, in fact. So why Apple should come up with a new language? Um, so it's more like, give me a second. So I was quite excited to learn a new language, and that's how the whole idea of this session started. Also, I was part of the last session, so there were a lot of questions and discussions. So we decided again to have one more session on Swift. Um, so so when before we jump into Swift related things, let us go for a bit of history. So this guy is called Chris Latner. He's heading the compiler and the development tools department at Apple. He's the one who actually created Swift programming language. So Swift is heavily influenced by a lot of other programming languages in the community like Ruby, C#, Python, and see, his original project called LLVM. He's the one who created the first a tool set called LLVM. It's a compiler infrastructure. In fact, it contains compilers, syntax parsers, and so many things, which is pretty much faster than the other non-tool chains. Like GCC is one of the most famous, compiler. It claims that it even compiles the source code 3 times faster than GCC and the related tool chains. So initially he was a research intern at Microsoft. When he developed LLVM compiler, he tried to integrate a lot of Microsoft languages into this. I mean, the C# and many other languages into that. But he just came out of Microsoft and started working at Apple. And the effort for Swift was started in 2010, and just like in 4 years, it's actually pretty low, very small amount of time to come out with a meaningful result. I mean, to create a programming language right from the scratch. So so it was so this is the history of Swift programming language. Um, why we need to use Swift? So Aromel already discussed a few points. Why we need to use Swift? At least those who try to adopt iOS development, they might be knowing that it's more of a it's a pain to learn Objective C, at least for some people, because the world goes upside down, right? When you write every return type on the left on many of the programming languages, you just write it on the other side. on Objective. So it's just opposite in many sense. But it's very powerful. At least those who crack that tough time adapting that language, they must be knowing that though it's called C. C is like a bit scary when we talk about pointers and so many other nightmares. But it's much more powerful, and looks like Apple is the only one who invented the space. I mean, improving Objective C. Um, so basically, they are owning it. Nobody else is actually actively using Objective C for development. Uh, so why Swift? So just like I described before, Swift is adopting the newer compiler technologies and the modern syntax, and it's definitely heavily influenced from other languages. But it's pretty modern when you compare to Objective C, maybe compared to any other languages. It's pretty easy to learn if you look at the syntax. When it was introduced at Apple WWDC, what they claimed is Swift is Objective C without C. So you don't have the baggage of C with Swift. So that's the one plus point when you think about adopting this language. There are some new stuff when you try to learn a programming language. It's pretty tough to learn. You create a console program, or some kind of it's basically a console program, or create a UI application. All these things are there. You have to take the whole pain to create these basic apps and write the code. But with Xcode, with the introduction of Swift, they also introduced two new tools called Playground and REPL. Playground is something you must have already seen in many demos, that you can write the actual code, see the output here. Even you can visualize a lot of things, just like this. So these are so this actually makes our learning more interactive and helps us to learn faster. You don't need to really bother about creating sample program, writing a main function, or just like you do with C or C++ before. You can straight away write a code, and it's like a sandbox for your program. It even have I mean it has even things like how much time it has taken to execute certain algorithms. So how you can improve them. So before you adapt something back to your code in the production code, you can go and try out here, see the performance, and you can take it, I mean, improve it and take it back to your original production code. This is it's more of a code stuff. Like even during the debugging, you can actually write some programs. It's just like a console. Like you might have seen this with many programming languages like Python. Python is one has this kind of console. You can write the programs here in the debug console, or you can write the same thing and run it with the Experion Swift. With the string itself is a program. So it's a very easy way to learn, and understand a new programming language. Yeah, it's pretty transparent, and it works seamlessly with the Objective C classes and libraries and frameworks. So how is this possible? So every other Swift program you write, it runs under Objective C's runtime, which means Objective C and Swift shares the same runtime. Again, if we explain it further, the Swift code compiles into Objective C's the machine code. It runs exactly in the same runtime. I guess we discussed this last time, like how it's really possible. But yeah, this is it. So if you're writing OS X or iOS programs, there is an Objective-C runtime already existing. They don't need to reinvent a new runtime just for the sake of introducing a new language. Rather, they generate the code which actually matches with the architecture and architecture of the processor or whatever the platform they have. Yeah, definitely you can just due to the same, I mean, because of the obvious reasons, you can deploy this even with the previous versions of iOS and OS X because it runs on the same runtime, and it's actually widely adopted. Like in just it was introduced in last September, uh, and in the last quarter, in just 3 months, there is a programming language index, like what is the most popular programming language. So I Swift has jumped 46 spots, and now it is number 22 in the programming language index. I mean, based on the popularity of the programming language. Definitely, this is going to be even better in the coming months. But it's actually a very big credit for I mean, when we talk about the ranking of it's very tough to jump these sports easily. Okay, so in the last discussion, we had few questions like why Swift performs better than Objective C. Uh, why it could be?
Maybe it has less lines of code.
Um, yeah, less lines of maybe the final code it produces, but it fundamentally this is how it works. Like typically a LLVM compiler works. There is a source code. It parses by Clang or Clang, however you pronounce. Then there is an LLVM compiler. It has a low level optimization. It has a code generation and finally converts into machine code. Now, how this was improved? Here, you have two more level of optimization. Maybe many of you have started developing with Swift, maybe started complaining that my machine is very slow. I cannot compile Swift code. It's just because of this reason. It has multiple passes of optimization before it actually produces the final code. So Swift itself optimizes a lot of things, high level optimization, and then LLV optimize the code further. I mean, it's basically the same LLVM infrastructure, but this additional step helps to save a lot of lot of things. There are a few things, like for example, if you have a virtual functions, like you know that in Objective C's terms, like if you have a virtual functions, definitely it has a package of virtual tables, pointers, etc. All those things. But in this additional pass, Swift remove if there is no derived or there is no use of virtual, there is no need of it, right? So those kind of optimizations are done in this high level optimization with Swift itself. So there are a lot of internal details about how this actual optimization works. But yeah, these are some of the we can see it in a very abstract point of view. So this additional optimization actually makes Swift code runs faster. Even there are certain debug switches. Like there is a new one introduced like zero fast, which means it's pretty close to C's runtime performance. C language, so which is a very big thing. When you write a code, just like in so the problem with the other programming languages like Python, the code is actually 10 times slower than maybe the C++ program. But when you look at the programmer's productivity, it is 10 times faster, right? You can write things in a line or two, where you have to write hundreds of lines in C++. But but if you look at Swift, it is actually give you the the productivity of a scripting language, while it produces you the performance of an actual native programming language. So that's a plus. I think this is the only kind of a language in that category.
You mean that it takes more compiler time but execute faster?
Right. So it exactly generates the same machine code, just like Objective C. So you will get the same performance of Objective C, or even better, because of this high-level optimization stuff. Yeah. So now let's start with the.
And performance is similar that
Sorry.
like Objective-C, right?
Sorry.
Session, I'm
In the
not
previous.
expert in Swift or
So I can get
Objective-C.
your question.
Sorry, I'm not first for others. I'm not expert in Objective-C or Swift, but on the recap session, I don't know whether I am wrong or not, but what I heard is like Swift compiles fast and runs similar to Objective-C, but you are saying the other way.
Actually,
Like compiles slower and runs faster or similar to Objective-C.
It actually compiles slower than Objective-C.
That is a fact. Okay.
Right.
Yeah, that diagram says so, which is aligned to your comment. Like, since it has a one more level of optimization, of course, it will be slower.
Right.
For compilation.
Right.
It's actually recap session. What I'm saying. Recap session.
This is the compilation. It's about the compiler.
Yeah, and the recap session. That person, I don't know his name. He told the other way around. I mean, just for clarification.
Okay. But it actually compiles slower than Objective-C.
Yeah, he was mentioning like in Swift we just need to write less number of lines of code.
Yeah.
So that. Yeah. Right now it is in detail.
Right.
Yeah.
Yeah. Yeah. Actually, they are improving a lot of. So there are even they have released at least 2 versions now with Swift. So in September they released 1.0. Now it's 1.2. So they have improved a lot of in terms of performance, language constructs, and they get feedback from the community. So they keep on improving the language further. Okay. So today we will be focusing more in terms of the language, not exactly into iOS development. So how it is different. So like you know, iOS to develop iOS applications, you have iOS SDK, right? So you can make use of iOS SDK both from Objective-C and Swift. So in this session we will not be focusing anything on iOS SDK related stuff. This will be more focused on the language itself, how we use the certain concepts. Again, this is not like a copy of the Swift book, or I handpicked few things which found to be very interesting. Maybe I won't be able to cover everything in detail, but yeah. So if you know more about it, please feel free to share it with the audience. Okay. So let's start with the enumerations. So enumerations, you must be knowing, it's just similar to any other programming languages. You can have different cases like you can say, okay, compass point north, south, east, and there are different cases. It's nothing different from a typical programming language. But how it is being used in Swift? So you know that you can initialize just like this. So where direction to head compass dot east, or when. But in the next statement, you can see that. You can see that direction to head is initialized with the dot east. So how it is different? So the compiler is smart enough to understand that the type of direction to head is already initialized with the compass point. So you don't need to explicitly specify that it is compass point again dot. I mean that full length explanation is not required when you specify this. So when you write a switch case, it looks like this. You have switch and dot east, west, north, and just like you don't need to completely specify what is if it is compass point or not. So what additional you get with Swift within enumerations? There's something called associated values. The associated values are it can store a value associated with each of the members in the enumeration. Okay, so that value can be different type. If you look at any programming language, you can have only one type. I mean, mostly if you look at C or C++, you can see that enumerations are always int. You can have different values, but these are different, it cannot be different types, right? Hmm?
Usually support 4 types. Byte, floating, and
Yeah, so it's all of same integer type, right? So typically integer type. Um, but here you can have your own version of, I mean, you can have your own type associated with each of the members. If you look at here, you can see a barcode of a UPCA type where 4 different parameters used to construct that value. On the same time, for the QR code, you can see it's a string. Okay, so when you initialize a product barcode, you can initialize like barcode.upca, these 4 different values, and probably when you initialize it with QR code, it is just with .qr code ABCDEFGH. So it's very powerful to hold different type of values. So like this, just imagine like how do you represent it with a class? You have to write 2 different classes, isn't it, to represent this? But you can just it's very powerful to create with enumerations itself. Then how do you compare? You can just initialize. So enums, you must be knowing that enums are mostly used with switch cases a lot. So when it comes with switch cases, you can just express it like this: caselet.upca, and compare with whatever the number you have, and see if it is matching. Right? Everyone is with me? Yep. So it's very powerful to handle this kind of complex case checking. Right? So you don't really need to take the baggage of that class infrastructure and all those things to write this kind of small things. You can express a lot with the enumeration. So basically in Swift, there are 3 major things that are heavily used, like enumerations, classes, and structures. These are the building blocks of Swift. Right? So the next one is switch case pattern matching. So when you have a case, you have a value to compare with it, isn't it? But okay. But you can have a range comparison as well, right? So here with the case, if you have a value here, you can have a close range operator with a triple dot. So the range you can say 1, 2, 3, 4, 5. When it is half close range operator, I guess we have discussed this last time. There are these are the range operators. You can you use it in with for loop, while loop, or even with switch cases. So you can have this kind of pattern matching with Swift with switch cases. Clear? Right. So the next one is properties. You must be knowing that what is a property. So you can have associated values with structures, enumeration, classes, or there are 2 type of properties. So what is a property? You have a class, there is a class member. Simply it is called a property, right? So there are 2 types of properties. One is a store property. Store property is something like you actually hold the data in the class, right? You just hold the data. It's like a person's age is like 30 years old. Then you can say that okay, it's a stored property. It can be a constant or a variable value. But in store property, again, there is a subclass. There's something called lazy store properties. In lazy store properties, it initializes with a lazy keyword. So when you declare where age equal to with some default value 0, you can mention that it's like lazy where 0 where age equal to 0. So I'll show an example. So it is actually cannot be a constant. It is initialized when it is first time accessed, right? So there are certain situations where you don't know what is the value, with what object or what value the property should be initialized. So in those cases, it helps a lot. Also, you don't need to spend memory if it is not at all used, right? You don't need to take the pain of executing the whole code for initialization or uh, memory or anything for this lazy properties. So here, take a look at this example. You have a data importer class. There is a data manager class. You can see that the importer is a lazy property. So then you hold the data as a store property. Again, it's a store property. So when you add something, you say m.data.append element 1, 2, 3, right? So you just append it. Still, though this data manager is constructed, still this variable is not initialized. So this will be initialized. This constructor will be or the init will be called on the first access of the of that property. So when you write m.data.importer and call some of its methods, then it will be initialized, right? So that's lazy initialization. Exact situation. Suppose if you are holding an image, okay, if it is a user class, you are holding some image data. Probably you are importing it from Facebook. You don't know what is the data, what is the size of it, right? So once you complete the login, you probably can get that data back to your this class. So it will be accessed. So it's more of you can see that it's already the code is written there. Yeah. So for example, just imagine like a CSV parser or importing some file. So in the screen, if you the user, suppose if he chooses a file and try to import it, I mean the files are not exactly works with iOS development, but yeah, but just for the sake of an example. So unless you get that file and know what exactly it is, so it can be wrapped within the init of that particular function. So the object will not be initialized at all. So if you want to save some memory or if you want to delay up the initialization, probably you can, or maybe this data is initialized with an external variable, right? So the file name is received from a separate entity. Just imagine that situation. So unless you get that, you don't know with what it should be initialized. So there is another type of property called computed property. So computed property, as the name says, it's just computed at runtime. Suppose if you have a rectangle class where you have height and width, how you calculate the area. So when you call area, you can just multiply height and width and return the area. So this data is not stored. It's calculated at runtime. So these kind of properties are called computed properties. Right? So here's example. Okay, so the next one is property observers. So you have a property, you have a class, you have a property, you can get and set values. But it is very nice to have some kind of observation mechanism when it is being set. For example, if you have a model in your program, okay. For example, you are getting a temperature from some sources, maybe from a API call or somewhere. But in that case, if you want to update the view controller, just imagine if you want to update the view controller. So these kind of properties can help you to do certain actions when a certain property get updated. Maybe it is not required for every other property, but it's just like an extension you can add to a property and embed a piece of code in it. Just for example, here is a temperature class where it is set as 26 by default. When this data is set, obj.current equal to 32, immediately the will set function is called. So there is a default variable passed or a built-in variable passed called new value, where you can access this the new value with actually there's a new value built-in variable. So the next one is did set. If once the operation is complete, you will be redirected to did set method. So if you want to do something with the old value, you can do with it, right? So this is called property observers. So this is very powerful, but um, it's mm,
Like
okay.
writing our own.
No. I was thinking about comparing it with the key value observers in or selectors in Objective C. So just forget about it. It will make it complex. Okay. Um, uh, right. So next one is closures. Closures is similar to blocks in Objective C. So those who have used blocks, it will be quite familiar to understand closures. Closure is like a piece of code where you can pass around in your program just like a variable, right? So if, for example, if you send a request and you get a response, how you pass it? You don't need to write this method in some classes and execute a lot of things, and you don't need to do that. As soon as you receive a code, receive a response, you can write a piece of code to do whatever you want with that response. So this actually ties up the data and the program. You can just type um, tied together, and it's pretty clear from the program itself, like, okay, this is what it's supposed to do with when you receive a response from a web server. So just like that, closures are heavily used, and there are a lot of cases where you should use closures. I'll come to that later. So it's a, just like I said, it's a self-contained blocks of code where you can pass around in your code, and blocks in Objective C. Um, so I'll take an example to introduce closures. It also cover up a few interesting things with the Objective C. Okay, so rather than just taking an example, I will also talk about a few other interesting aspects of Objective C. So if you see, you can see cities as the variable, and it calls cities.sort. It's a built-in sort function for arrays. So you must be knowing that this subscript operator declares a string array. It says basically a string array that says something called type inference. When you declare a variable just with a subscript operator, a string, and the compiler knows that it's a string array, so you don't need to explicitly specify cities colon block of string as its type, right? So that's called type inference. When you call sort, you must be knowing that you should be able to provide a compare function when you write a sort function to compare the actual element and the first element and the second element, right? So with a block within the function, within the curly braces, you can mention what is a it's a basic delegate. You can say a comma b, that will be the first parameter, and bool is the return type, just like you mention a function in Swift, and in describes the body. In just describes the body, and you can write a function just after in. So it says a less than b. So the other interesting stuff is that you don't need to specify a return here. If you noticed, you can specify a return here if you want, but you really don't need to specify a return there. The compiler is smart enough to understand that the return type is bool, and the operator you have mentioned there, the less than operator returns a bool, and it just take that is as a default return value. So it's a lot of syntactical sugar. So you lot of things, if you look at in a conventional programming language, it looks like a magic. And how does this work? Most of the things are, again, in the next pass of compilation, the actual code is getting generated. So if you look at this again, Swift always want to optimize everything, just even the syntax. They just need to reduce the number of lines or number of words, characters, everything possible to express something. If you look at here, this doesn't look good, right? You have a empty, the parenthesis start, then a block. It's not really required. You know that it's a block, right? This is the start of the block. So you can code like this. You can just remove it. So you don't need to it's called trailing closures. You don't need to specify the parenthesis along with the closures. You can just omit that. You can even write that, but you can also omit that. So here again, if you want to specify the, again, I would say if you want to specify the type here, you can very well do that, but you don't need to, right? So okay, so again, the next one is like you have a parenthesis here. Again, it's not required. You can just mention like this, a comma b, right? It's the same. You get the same result. Okay, so here, if you look at the a comma b stuff, there is a bool value, but you already know that this is a less than b, right? It returns by default. It returns a bool, and you can just omit that bool from here. Actually, I actually skipped to add one more slide. You don't need to really write a comma b also. There is something called positional variables. You can access the first and second parameter using dollar symbol. You can say $0, comma $1. You don't need to have a name. If you know that that is the first and second parameter, you can just access it without even specifying anything. So whatever passed to that particular function, any number of arguments, it will automatically gives a positional value, and you can access it with the dollar symbol. Okay, good. Any questions? Haven't seen exception handling with Swift. But even if you look at Objective-C also, you don't do much of exception handling, isn't it? Do you? Yeah, it's so it's basically even the function calls and all those things are it's actually a messaging runtime. The runtime handles all the. It's not like a typical function call, if you know. So there is I haven't seen any exception handling with Swift. I guess it's not there. You don't really need to have exception handling. So again, when I try to understand what the way to write Swift programs, when I come back from this conventional programming stuff, you need to have a class, lot of functions. You don't have the flexibility of writing blocks and so many things. But you know, you have all those. You'll understand better when it comes to optionals and so on. So when you need to have an exception, when there is a null pointer, right, or a value which is not acceptable, right? So we can very well avoid that situation also. To be frank, I haven't used exception much in my whole career, unless you know that framework or some classes insist to. I mean, the program insists me to do that. Otherwise, I always go for error handling. Maybe I'm totally wrong, but I prefer to do it that way. Yeah. Yeah, that's there. That's there. Objective-C is, you know, again, it has the features of C, C++, you know, all those things are there. Okay. So let's come to optionals. So this is a very, very important topic in Swift. So what is an optional? So when you write a pointer in Objective-C, it can have a nil value, or it can point to an object, an actual object. It's similar here. So there are certain situations. For example, if you have a stack object, it may not have any values. But I still call it pop. What will happen? So typically, how do you write a program? You just return a nil, or you return an object, right? So then I have to check again, okay, if it is nil, or you know, that kind of thing. So so optionals are used in these kind of situations. There is an uncertainty. There can be a value, or there could be a value. You are not sure that if there is a value coming in. Probably you must be knowing that, okay, when you send okay, when you receive a response, maybe certain parameters are not there, but still you want to initialize a class based on the language constructs. unless so every object must be initialized before you use it. So if you declare a float or int or whatever it is, it must have a value. But there are cases you cannot even specify 0 as a value, right? So I still remember, like, when you try to find index in strings. So what the old programmers they do is like, okay, they mention it as -1, because -1 is a, so you don't know whether it's -1, 0, or a value or some other value. There are a lot of confusions in the way you solve a program, right? If you look at Objective-C or any other old programming language. So this is pretty clean. It's predictable whether you have a value or don't have a value. If there is no value, it's nil. There's nothing else. So optionals must be used in these kind of situations. In fact, internally, optionals is again an enumeration, right? So you must have already seen that barcode example. So optional can have two cases where one can be nil and other can be a value. It's a generic enumeration T of have value as some, don't have some value. So it's again it makes use of its own construct. That's what I was mentioning before. It's the enumeration classes and structures are the foundation block of Objective-C. So many of these nice things are getting converted into a different form when it actually compiles. Okay, so I guess I should move a bit more fast. So here is an example. Okay, you just pass something, and okay, suppose if the pass returns, if there is no response at all, response can be also nil, right? So what happens? So you don't have a value at all. So in those cases, you should always work with optionals. Again, optionals can have a value or it can have another, a real value. So when what do you do? What you are supposed to do to get the actual value from an optional? So there is an operator, that exclamation operator. You can see it here. Let x equal to age. This is how you unwrap an optional. But interestingly, your program will crash. There is no exception handling, but your program will crash if you access or try to unwrap a nil value. So what you'll do? So should we introduce exceptions here? So this is something called optional binding, right? Let's take a better example here. You have a class called person, residence, and address. If you look at all the properties, it's all optional. Residence is optional, address is optional, all these values are options. So it can go wrong at any point. So what you'll do? You can, there's a powerful statement called if let. If you say if let home equal to, I just initialized a person object called Paul and Paul.residence. If Paul has a value, Paul.residence has a value, this object is unwrapped and assigned to home. It's not an optional, it's an actual object, right? The home residence is the residence class, so it's an actual object. Home is an actual object. Then next one, so probably you are supposed to access a building number, right? So you can combine this, like if let. So if let is something you use for optional binding. So otherwise, how do you check this in Objective-C? If this equal to nil, then you assign or not equal to nil, you get the value, right? So you don't need to be that explicit here, but again, it doesn't sound so good, isn't it? It's pretty easy. It is good with one statement. It's just good with one statement, but it's not something called a chain statement. It is not good. So there is a better way to do it. It's called optional chaining. In optional chaining, you can get this value here. Again, this will be an optional, right? You can combine this just like this. Paul.residence, question mark, then dot, then address, dot building number. Now, this exactly compiles back to the, this gives the same result of give the result of the same stuff. So the syntactically it's more clean, but when it creates actual code, both code generates the same one, right? So this is called optional chaining. Again, there is one more problem. So you can combine that unwrapping. If you add just an eFlet here, you will get the. So this is bit more clean, isn't it? So if let building number equal to pol.residence.address.building number, then you can do something, right? So we talked about what we talked about. So optionals binding, then optional chaining, then plus optional chaining, binding plus unwrapping, right? So it's that easy. So just you can count the number of code here, right? That same stuff you can write it in a single line. Okay, so initializers are equal to constructors in any other programming language, and again initializer is in Objective-C. But there are two types of initializers in Swift. One is called convenience initializer, and the other one is designated initializer. Okay, so what is convenience and designated? Okay, don't look at it. Designated initializer is the default, the general primary initializer you have with your class, right? Just like you write any other. But there are certain situations where you need to initialize an object with just for the matter of convenience. We initialize with some default values, or you can create a small abstracted version of an initializer. So how do you do it? So it is called convenience initializer. It's a secondary initializer, but it's actually make use of the designated initializer to initialize an object. So it must call a designated initializer to initialize an object. Look at an example here. So here, this is the designated initializer. This is the original initializer, right? Then when you if you look at here, so it accepts one parameter, but you just want to create an empty, just equal to, you say food, where f equal to food with empty braces. So how do you do it? It's another version of initializer, but it's actually separated with convenience keyword, right? And it just called the other initializer with the default value. It's just like an abstraction. But there are more things connected to this, like when you override in terms of inheritance. Typically, the convenience construct initializers are not overridden. You don't get the copy of it, but you can mention if you really want it, just with an override thing. So that's called a convenience and designated initializer. So it's like it makes the code a bit more cleaner. So I have written C++ classes where there are a lot of initializer, and I copy paste the same code. So this looks a bit more strong in terms of readability, and so a class shouldn't have a lot of designated initializer. Like you can have a very complicated big initializer, but probably you can create a lot of convenience initializers. That should be the way to handle the initializers, right? That makes sense, isn't it? Rather you copy paste everything, you can create wrappers to help with it.
The designated initializer is something similar to a parameterized constructor. Is it something like that?
But
Yeah. This convenience initializer, right?
Right.
Is that something similar to a default constructor in C++?
You can have parameters also with the convenience
Inconvenience?
initializer. The only thing is that you need to mention convenience here. So
In
it should
this
make use of another. So the default constructor is like, this is a default constructor, by the way.
Right.
But it's not necessarily to be a default constructor. It can have parameters. Probably you can get single parameter and expand it to something else and call the actual designated constructor.
Okay, so in that case, does a convenience initializer automatically happen when you declare a class? I mean, will a convenience
So the
initializer...
interesting point is that it is just like another initialize function. Typically with classes, what we do, except apart from this constructor ones, I mean constructors, we create class methods or extra methods to initialize for our own convenience, right?
Right.
So you can actually avoid that with the so the syntactically it looks very clean that where x equal to this particular food with that parameter. So it just look like you are initializing an object, but it's not like food dot init default or something. It's nothing like that. So just try to avoiding it.
How do you invoke? Are you coming to that? Like, how do you invoke convenience in it and
Just like you initialize an object.
That's all.
So it's like with the designated one you can say food var f equal to food with that one.
Okay.
Right?
Thank you.
Sarath, 1 second. Well, I'm not very much clear about this point. Like, convenience initializer is okay. Even in C++, you can write a default constructor without any parameter, and you can initialize many things. Okay. Or you can even create a constructor with some parameters, and you can, initialize.
It's more or less same. You can also have an initializer without convenience here. Here also you can have. So it is just mandating that, I mean, the initializer happens only in one place, and this is a kind of wrapper, a convenient wrapper, right? Just like I mentioned.
This in term it will call that actually from this function it will call the designated initializer.
Yeah, it should call a designated initializer. So it's must. So it's more in terms of I don't know whether you should really use it, but if you use it looks pretty neat. That's it.
Okay.
Yeah, if you can also, that's what I was mentioning here. You can, if you avoid this convenience one, this is going to be another initializer, right? This is going to be another initializer.
Yeah.
You can say this self dot name equal to unnamed. You can very well do that. But when you write a class, this this gives a better impression that only in this place the initialization happens. And this is a convenience guy. I mean, this is a kind of secondary wrapper guy, where you can so it's syntactically more clean and creates a mandate that you should call the
basically on the usage level you'll feel the code much clean. That's it, right? But when the same we can do in C++ as well. Like if you have multiple parameters in a class, or
so if you for example if you look at certain APIs. Or class initializer, you can see that there are long list of parameters where you need to pass, but it is very confusing whether you should use those ones or not, right? You have to pass a lot of nil, but that is the actual initializer which initializes the object. But if you can wrap it around in a simple way, for example, create file. If you are creating a file, there are file name, what is the mode of writing, what is the privilege, and so many things, so many parameters. But if you create a simple wrapper, just a create file and write mode, read or write, I mean read or write mode, that's it. But it might be using the actual API, So that it's just mentioned, I mean meant to be kind of a wrapper. That's it. It doesn't make much sense. If you can duplicate the whole code here also.
I think for this particular case, I'm not seeing a much.
No, it doesn't provide you any any value in terms of runtime or compile time. Nothing is there.
I mean, what I said is like
it just looks clean. That's
well,
it.
maybe it is
Right.
Hey, maybe it is actually setting up some default values to all the objects.
That's it. You can even accept certain. I'm not getting any examples right now, but you can get a lot of parameters and adapt into your own terms. Maybe you have 5 parameters, 5 properties in your class. You are accepting some objects from random objects you received from some external class, and you can convert. It's like it even works like an adapter, right? You don't need to create another version of this.
Actually, in C++, if you remember, like we can have some default parameters for example, if so I can just call a constructor without any parameter, and so the default parameter values will be assigned.
Yeah.
So something like we can do in C++ as well. So I'm just comparing this and that, and whether we have any validation here.
In
So
C++, I don't think you can call another constructor from
a constructor, it is
from a
possible.
constructor.
Yes, it's possible. Yeah, that is possible. That is one case. One case, and another case is like
No.
in another cases we can use default
see,
parameters. I am saying.
I don't exactly remember. It's been quite long, but if I remember well, if you cannot call another constructor from a constructor unless it's a base class constructor. You cannot call the constructor of another
base class we can call.
Yeah,
what
you
I'm
can
saying,
call
now saying
base
is default parameter. I'm saying default parameter we can give, right? So like,
so you cannot write the same stuff in C++ in my understanding. So what we typically do, we create an initialize function, a private initialize function with the long parameter list, and probably we call to avoid the duplication, we wrap it in a function and call it from these two different constructors. But
a default constructor as well as a parameter constructor in C++, right?
Right.
So the default constructor is called when we don't have to explicitly set any default values to it.
Right. You don't need to, but
A parameterized constructor is given when we have to set some values whenever the object is initialized.
It's simple. It's like if you are inside a constructor, you cannot call the other constructor of the same class, unless you can call another function, but you cannot call the another constructor. In my understanding, you cannot call that because your object is not yet constructed, right? That this pointer is not yet initialized. Probably you cannot call it.
no. It's just function call. No need to be.
I don't. Maybe we can try that out, but I don't think it's possible.
Okay. Yeah.
Okay. Okay. So overriding initializers. So there are certain cases where you need to override the initializers. For example, in this example, you have vehicle. You cannot say what exactly the number of wheels for a vehicle with a vehicle instance, right? So probably you need to mention that here. Like if it is a bicycle, then it should be 2, and if it is a car, it's 4. So you can override the initializers in your derived classes. So the next one is extensions. So in fact, there are a lot of rules related to initialization. It's like a very big list. Probably you should go and refer the Swift programming language book. It contains a lot of rules and how, especially when it comes to inheritance, how the initializers come down to your class, and so many things are there. How the convenience initializers are used. So it's like a very big rule book. Even they have a kind of graph how these are interpreted. So probably you should go and check it out. But okay, I should mention a case here, but I haven't included that slide. Typically in in Swift, you should avoid initializing using init. Why? Most of your stuff you can, especially the properties and all those things, you can initialize, with closures. You can just say that if you have property x and y, you can say point in bracket x equal to this value, y equal to this value. The properties can be directly initialized, and there are certain cases where properties are nil. For example, that person class or address class, you can see that those parameters are nil. It is initialized by default. Then you don't need to provide another init class for that, init function for that, right? So unless all these criteria are not met, like you have to write an initializer, then only you should write it. If it is like you have a lot of optionals and all those things in your class, you shouldn't really bother to write initializers because it's not even worth doing it. That should be initialized with closures or external. Like for example, when you get a response, then only you initialize a class. So it is much cleaner when you say that this model dot xyz equal to this value. Then you embed everything in a. It's pretty modern than you write with the initializers. You don't need to bloat your code for that, right? Even then, how we can do it? Like the property observers and so many other language functionalities are there. So probably you can make use of them to effectively replace the initializers on those routines. Okay, extensions. Extensions is like extend, right? You just extend the extend a type. So suppose if you have not defined in a class of your own, you need to add, for example, UI view controller. You want to add one more function to the UI view controller in your program. How do you do it? So you can use extension methods. How do you write it? For example, int. Int is a default variable. I mean, a standard type. Extension int. You can write a function +1, right? Then you can say return self +1 equal. Just increment it and return. So when you write something here in your program, this service is available. That var I equal to 5, I dot +1 or 10 dot +1. Okay, it's again an object, right? I dot +1 or 10 dot +1. So it's just it's again a syntactical sugar kind of thing. But you can work or extend your functionality, or if you want to improve something you receive from a framework, or those kind of things you can do with extensions. Clear? So here is another example, a better example. You can say extension double. So you are extending double, and I am trying to interpret everything in meters. So if you look at the code here, return self is, which means double is like a m. There is I haven't mentioned it here. There is something called type alias. There is a keyword called type alias. So instead of double, you can see that distance or something. So double will be treated as that type def in C. Right, so you can call type alias and probably you can extend it. So you can, so it doesn't look good with the double, right? You have no idea whether it's a distance or something, but still you're trying to interpret it in this way. So it's represented in meters. So whatever you try to do here, like 3 feet. So we have this definition here, and when you come to 3 feet, 3 dot feet means it is 3 feet is like this much meters. So you have that routine here, right? Just like this, you can extend it. This is just a way. This is a property, right? You are adding a property to double. If you notice, this is a property. Similarly, you can have functions. So if you remember, recollect the previous session, there are two types of functions: instance functions and or instance methods and class methods, right? Instance methods are always used with the instance of object, and the other one is with the class. So here I'm trying to extend UI color. So I want to have a color called chili red, which is not a service of UI color. So what I'm trying to do here, where chili red equal to UI color dot chili red. So this is a class function, right? So it's just initialize. So typically you are unable to do this, right, with the UI color. You don't have this kind of, so you are extending that one with the additional service. So you can have properties, functions, or whatever to extend your type. Clear? Okay, so this you must be knowing a lot. Protocols and delegates. It's nothing much different from how you are using with the Objective-C. Protocols, you know that it's kind of interface definition. It doesn't have any body or anything. It's just a statement that this is my interface, right? And we implement as the delegates in the classes, right? So here we have seen the delegates in the sorts, right? So it's similar the way we define delegates. So here, if you see, this is one example. You can derive a class from either from a class or from a delegate. Protocol, right? It's a class. It's a protocol. Then this is a better example. Something a bit more clean. If you look at there, I created a protocol called login protocol. There is a function login successful, login failed. So when I initiate a login, maybe there is an actual login class, and which derives from login protocol, and probably once you have this login thing, you have a view controller which derives from login protocol, and you have all these functions here, right? Simply you can get all those delegates back to your delegate calls back to your application. So in fact, okay, this is a general question. Maybe all of you are knowing it. Why we need delegates and protocols? It's simply the part of MVC architecture. So it's a basic design pattern stuff. Like you need to isolate your views, you know, to certain type. You don't need to expose everything in a view, or you know, the view don't really need to know. Like for example, if you add some gestures, it doesn't need to know who's gonna handling it, right? It only needs to know a certain protocol where it passes around that gesture thing. It doesn't need to know whether the model has this service or the view controller has this service, or it doesn't need to know that much of detail. It's actual you know, kind of data abstraction. So it's like, you know, you are programming to an interface, not to a class or something. So it's more in you know, when you look at the actual MVC pattern, it's more in terms of, you know, uh, it's a better design of that program. Okay, so here you can see that how do you work with properties. So you have seen a class function. Now, how do you work with the properties? So you can say that some property is equal to get and set, right? So I'm overriding it here, and you should also override the property here, right? So these two functions I have already written there, and now you have some property where you have will set and it set. I mean, it's just for the sake of it. I just written there. You can update your UI, do whatever. Maybe you can add some logging code here, like this value change from this. So all these things that you can do in your class. So, but you just need to mention that in your protocol. Okay. So it is nothing different. Okay, give me a second. Okay, so many of you know you have already used generics, right? Maybe you need to use generics. It's like, you know, give so generics helps you to wrap algorithms and all those kind of stuff. You know, you can have, for example, if you are sorting something, you can have, you don't need to write it multiple times. Or okay, let's take an example here. If you want to swap two ins, like in the old way, I'm sure none of you write code like this, but swap in and swap string, you need to have two different functions, right? Which accepts in out. Okay, that is another interesting stuff with Swift. How do you specify that something is out? You will get a return value, so that you can specify with in out. So typically, if something is being returned, like especially with this value types, you should mention that it is in out. Then only you will get the value back from the, if it is being modified within the function, then only you will get it back, right? So when you are trying to swap two values, the actual values must be changed. So you have to specify it with in out. So I haven't checked whether there is an in and out separately, but in out is typically used. But in you don't need, right? Probably out is also doesn't make sense. I guess it's only the one. Huh? Yeah. So there are no concept of pointers in object. But interestingly, you can see something here. It's a bit strange, but yeah, ampersand you have to pass. So it's giving a hint that you are passing a reference here. Then yeah, just like I mentioned in the beginning, that it's Objective C without C, right? You don't have that C construct, but it's still heavily rooted to C related stuff. Okay, so so you are swapping the so you don't really write this a function like this, right? if you want to swap something, how do you write it? So you can pass a value here, swap t, in out a b. It's all type of t. Then probably you can mention equal to t equal to a equal to b, like the same routine here, and swap a and b. Right? So it's pretty clean. So you can write it with a function. You can also work with structures or classes. You can use that generics anywhere. Like, you know, if you want to create a stack like this, you can simply create stack of t with items, you know, that t as a type and t as a type and probably the function push and pop. So you must be noticing an interesting keyword called mutating. So I'll come to that later. But this is how you can define a structure of a templatized structure, right? So yeah, so this remove last and append are all that, you know, general service from the array class. Okay, clear? So suppose if you want to extend, suppose the stack class is not defined by you. Now it's written by you, right? But suppose if you want to extend, in extensions also you can use generics. You can mention that extension stack and probably top equal to, maybe the stack is empty, that's why it's returning t question mark. So it's like an optional, right? It's returning a nil value if the stack is empty, right? Okay, return nil is just for the sake of it, but you should pop out the last value and as first value and return it. Okay, so there are certain cases where you need to put constraints in data types, right? How do you put constraints in data types? Like, for example, if you are equating something, it should be equatable, right? There are certain times maybe it's not possible to equate. So maybe the classes you define, maybe it's not equatable. So in those situations, you can put a constraint saying that it must be a class or a protocol. You can say it's NS object, or you can say some protocols, and you can say that in the T colon equatable. Equatable is a protocol. So whichever class derived or derived from equatable is acceptable here. So then otherwise you will get a compilation error saying that it's not comparable. Clear? Okay. So we saw that interesting mutating thing, right? So here it is. So the structures and enumerations are value types. Classes are reference types, right? It's simple. So by default the properties or values of a structure is cannot be modified within from an instance method. We'll go with an example. You can see two functions here. The first functions, it doesn't modify the actual object. It's something like a computed property or a function, right? It just returns, compute something and return a new object which doesn't affect any of this self.x or self.y, right? But here if you see, scale actually modify the current object. So it's basically a rule that the value types shouldn't be modified within by a function. When you modify something, the actual object gets changed. That self itself gets changed. It is immutable. Immutable means it's when you change something, it generates a new value. So the actual reference get changed. When you say okay, I don't have that slide. Okay, if you say point p equal to point, and when you change something in P, it actually changes the whole object. So it shouldn't. It's a simple mechanism where it makes it cleaner, saying that okay, this guy is actually modifying the object. So I'm not sure, if you look at C or C++, it doesn't have that kind of constraint. If you can write a code, but this actually makes it precise and clear. It makes it predictable that this function modifies something. So it's that kind of stuff. So yep. Now let's talk about operators. Suppose if you want two user types like vector 2D, then vector 2D plus equal to, then plus equal to, then how do you do it? Vector equal to, you just defined it, just add a user type. So you have to declare a global function. So these operators are only allowed in global space. It cannot be part of a class or something. So it should be in global space. Then where you can mention that vector plus equal to another vector, or this is like a compound operator. Like here you have to use in-out. Here you have to use in-out in compound operator, left equal to vector 2D, and so which means we are actually modifying the leftmost operator, right? So this is how you define operators with Swift, right? Suppose if you want to define a custom operator. Okay, now you have all these regular operators, plus equal to star, all those stuff. So if you want to have a custom operator, so suppose triple plus equals is the meaning of triple plus is like doubling the content. Okay, in that case, you have to mention that it is a prefix or postfix function, like prefix plus plus or postfix. If where that operator comes, if it comes on the left side of the object or the right side of the object, right? That is prefix, and you can define your own stuff. In addition, even there are another stuff like when you talk about operators in the advanced level, it is more like you can have the associativity, precedence, and so many things, like right plus. So star get precedence over plus operator, right? So that kind of even precedence and values can be even defined with this custom operators. So this is how you define a customer, but you have to declare it there. In the global space, you have to declare it first. Without that, it won't compile. So you can call it here, let double equal to triple plus vector, right? Right. So we were talking, we are coming very close towards the end of the session. So we talked about like whether, okay, now we decided to do a project in Swift. So the problem is that a lot of frameworks we are using is not written in Swift. You don't have a Swift interface. So a Swift program can only talk to a Swift program, right? So it's a very tough deal. In that situation, what we will do? So Xcode also already, or this compiler infrastructure already provides a mechanism called bridging. So you can call any external or third-party Objective-C frameworks with Swift. Here, something like this. It's even, you can also call a Swift library or framework from an Objective-C library also. I'm not covering that, but it typically happens the other way, right? It's very rare that you call an Objective-C framework from a call a Swift framework from to an Objective-C stuff. So typically this is the way it is. You just mention a bridging header, saying that okay, it's just like a bridge. It's just a .h file, and you mention which is the framework you want to import and which is the header file you want to import. and do some compiler stuff. I'll just demonstrate that now. You need to change certain things, and then you would be able to access those functions from your Swift program. So it looks like very magical, just for the sake of, I mean, you are just adding one header and change a few compiler settings, but the compiler is or this Xcode itself is able to understand what are the different exposed functions and all those things. Even you can get it in your own language. I mean, you don't get that Objective C baggage there. You can all the delegates, everything you can define in Swift itself. So I'll quickly give you a demo. How do you do it? So let's try with this Facebook SDK integration. Okay. So I'm not going to run it because Facebook app needs to have, an app should be created. There are a lot of things you need to do in an app. But I'll just show how you access certain things with the Facebook. Okay, SDK. The first step is you have to get the Facebook framework. There are a lot of ways to get it. You can either clone the iOS SDK from the GitHub repository, or you can use dependency managers like CocoaPods to get it in your workspace and compile it, or you can just get this compile framework as a download. Okay, so you just need to add this to your project. The first step, you need to just just copy it here, and okay. So the next step is to go to your build settings, and okay, this is very type in Swift. So you have to mention install Objective C compatibility header. Okay, this must be yes, and then you have to mention a bridge header. So all you have to do is like to create a new file. Here you are going to create a new file, saying that it's a header file. Okay, maybe you don't really need to add that, but here you have to say so this is the default, I mean the header file for Facebook SDK. Now the next step is to come back here and probably you should drag and drop this. Okay, or you can just type in the name. Okay, I'll just do a drag and drop to avoid confusions with the path and all. Okay, now okay, it's very tough to manage code in a small screen. Okay, so okay. Mm, okay, I guess that won't work. Oh. There is a heavy path dependency here, so maybe that's the reason it's crashing. Um, okay, did I spell it right? Facebook SDK dot. Huh? No, no. The Facebook SDK. Okay. 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 Sorry. Sorry. Yeah. Okay. Yeah. Thanks. So it has compiled. Now you need to go back. Um, there are few things you can. Oh, okay. So here you can say FB. Now, suppose if you want to write the delegates, just start writing it like this. Login view showing logged in user info. Suppose if the user is like this. So, so it's like you didn't really feel like you are confused with something, or you know, I'm sure you are not left clueless like how you get all these delegates, isn't it? So it's just importing everything back from your Facebook SDK Objective C framework. So all you had to do is like, just create a header file. It's like a bridge. Just change the compiler setting and add this bridge header saying that this is my bridge header. And through that bridge header, you would be able to import all the Objective-C framework headers to your code, and Xcode will help you to generate all these functions, including this optionals and all those things. So by the way, this is actually an optional, but it's always unwrapped. So this kind of expressions we use when we say the values will never go nil. Maybe it's returning in an optional, but you are sure that this is not going to be a nil. For example, if you have a IB outlet in your storyboard, you're just dragging or a text box, you're just dragging and dropping into your Swift file. It will be a an unwrapped optional because you cannot be wrong. It's there. So those kind of things you can confidently give unwrapped always. Otherwise, you should mind those optionals data binding. Okay, so this is how you do it, and definitely there are more steps to create an actual Facebook application. You have to create a application in the Facebook console. Then probably you have to integrate those keys here in your info plist, and it will automatically pops up here. And you need to add certain code in your apps delegate to get all this callback, and you get redirected to this view controller. So that part probably you can look into later, but this is how you do it. Make sense? Right. Okay, so that's about it, and here's some interesting references. So these are the references definitely I refer to prepare these slides. Like definitely the Swift programming language. This is maybe the most definite piece of a programming language definition, or a book where we can easily read and understand. I have seen around. So the next one is like how you bridge this Objective-C and Cocoa frameworks, right? Then definitely there are a lot of resources in terms of WWDC sessions, 2014 sessions on Swift, where it was originally introduced. If you go through, there are three sessions in beginning Swift, intermediate Swift, and advanced Swift. These are mind-blowing sessions. It's like if you go through these three, if you spend 3 hours, you will definitely get a hang of not a hang. Actually, you will know the language quite a lot once you go through these sessions. And just wanted to share the last one. Maybe I'm a big fan of it. There is a professor in Stanford University. He previously had this iOS 7 tutorials, which is quite famous in iTunes U. Maybe it's not so popular these days, iTunes U, but it has got this Swift developing iOS 8 apps with Swift. It's really a great tutorial. It even have it has programming problems, reading list, and so many things. But it's like every week it's going on. So it's like an actual class is running going on in Stanford. Every week they post the new videos in and assignments on iTunes U. So it's like 15 classes are over, it seems. But definitely it's really worth watching it. So to just give a background of that professor, he worked with Steve Jobs in Next Computers. So when he was out of Apple, he worked there, and he quit his job and now teaching at Stanford. So he knows the lot of internals that like how does this work and so many things. So it's really an interesting tutorial, but you have to spend a lot of time watching it. It's like 1 hour per session. Yeah. So that's pretty much. Now you can ask questions or. How do you find it? Was it useful for you?
So, any questions? No? You already explained everything very clearly, and
like
there's no
everybody
question. That's
has,
awesome.
it's like everybody got clarifications or everybody is confused.
So what is the actual stat? So everybody is confused, or everybody got it, everything?
So in my conclusion, I mean, even I don't know the objective C anyway. I mean, what I feel advantage on Swift is like it will improve the productivity for sure, because many new features and easy to use thing. But I other than that, I think you already told the compile time maybe more than Objective C. And again, what I feel is the high level compiler, high level optimizer they put, maybe that is for optimizing the new construct to the uh, objective level things. That may be the reason. It may not be to improve the performance of the compile machine code. I feel. So I feel the performance may be same of Objective C, and the compile time may be more than Objective C. And the advantage, what I feel is, the productivity will increase for sure. What do you think?
Yeah. So what first talk about productivity. So I'm sure productivity, or in the when we talk about the learning curve, it's pretty easier and faster you can learn when you compare with Objective C. So I'm sure there is no doubt about it. Uh, second thing, there are a lot of things you can do with Swift in terms of with the default data types, like arrays, dictionaries, and list, and so many other default data types. So in previously, like from its roots, Objective C is from C, and there is no standard. I mean, library support for a lot of data structures by its own. So the iOS developers heavily depends on NS objects, right? NS array, NS string, and everything is NS. So it's like a separate library altogether. So it's like that the language itself has a lot of support. So you don't need to learn something totally radically different from the language. So it's like you get a lot of things by default with the language, right? So in terms of productivity, I would say it's pretty faster. So even you must be knowing that many of I am, as I said, I'm not a full-time mobile developer, but when I write code in both Objective C and Swift, I feel this is pretty faster. Like I can write code much faster than before. So that's something we want. Um, then when you talk about the performance, again, when we come back to the optimization stuff, the machine code is compatible with the architecture, CPU or the processor architecture. So there is no change in that. But like I said, there are a lot of things Swift compiler improves, like the devirtualization stuff I talked before. Like if there is a virtual related stuff which is not using, the compiler is smart enough to detect that and remove it, though the programmer declares it. Right? You defined a lot of class hierarchy, but you are not using those objects. You have all this virtual related stuff in there. But those kind of optimizations can be done by compiler, which is not. I don't think that kind of optimization there with Objective C, because of, again, it's from its own roots, right? It cannot be too different from the original GCC related stuff. So that optimization helps to reduce the code a lot. The devirtualization is just one example. There are a lot of other things which actually does it over the Objective C code. So when you there are cases, there are a lot of. I found a very interesting discussion on Stack Overflow, like comparing the performance of sort, and compound object sort. I mean, it was even demonstrated in WWDC. So it was, if I remember well, the performance was 2.3 3x something. The time was 3x. When you say x, it's like when you compare with Objective C, Python, Objective C, and Swift. Python takes more time. Objective C comes just below the Python, and Swift even much better than. I guess it's like a 0.5 difference when you compare with the Swift and Objective-C. So definitely the code generated will be optimal, but again it depends on what kind of code you have written, right? So
in this example, if it is a sort case, for example, you mean in these three cases the same algorithm is used across the three, and or in case of Swift they use the built-in library for example, dot sort
for
kind
example,
of
if
thing.
you write bubble sort, I mean the bubble sort is written in the same way, right? Except this language difference. So so the Swift is what it says, the Swift is much better at generating an optimized code comparing to Objective-C.
Okay.
Okay. So what was the other one? Is it done?
What was the?
So so the compile.
I'm talking about the advantage. Like the compilation anyway. Beginning itself you told like it will take more time since.
Yeah, I guess it's getting stabilized. Like, but definitely it will take more time than Objective-C. But if I talk a bit more about this type safety, so your code should be safe enough, right? It shouldn't crash, and there is a very strict type check with the Swift. So so whenever there is a strict type check, the compiler insert a lot of unnecessary code in between the. So if it is not a very sensitive application, you can simply avoid a lot of that kind of type checks. So there are certain compiler switches, like just like I mentioned, zero fast and those different type of switches. Once you introduce that, the code generated will be the performance is equal to C. But if you have a lot of type checks and so many other things, again definitely the performance will reduce. So there are compiler switches which you can make use of to improve the compile time and the code generation and all those stuff.
So finally, you feel like if I develop an app with Swift, will perform much better than an app made by Objective-C?
No, not always. That's what I was telling. Like if you just create a simple UI program, I mean app, I don't think it will be you will benefit much. But if something actually you can tweak into this kind of code generation.
That's why I told the significant difference will be on the productivity.
Algorithms and all those things. Sorry.
So that's why I told the significant difference will be in the productivity.
Right.
Okay. And another observation, what I thought of, like the C++, it's becoming, or it's, I don't say it is copying or something like that, but like the operator, the one example you told, right, the increment or decrement operator or operator overloading, those things, or the reference things and all those things, templates and all those were already there in C++, but it's like they are doing everything here.
That's fine, right?
Okay. No, it was not there in Objective-C.
So
that's what I'm wondering.
Objective-C is also there. Templates are there.
Okay.
Definitely templates are there. So I was just mentioning. So it's not like I'm only talking about the advantage. It's more about like how you use these things with Swift.
Okay.
Right. So like I also mentioned certain things like using extensions with the with the templates. Right. You can extend a stack function which is written by somebody else. So those kind of things you cannot do with C or C++. Right.
Yes.
So it's like you have that feature. It's like it has got all the modern language features from Objective-C or C, and even from another programming language like Ruby or Python or anything else.
Thank you.
So any other questions? No questions for you today? Okay. Good, and it was a really great session by Sarath, and thank you, Sarath.